So today our goal is to identify perfect squares of numbers and find their square roots. So what are square numbers? Square numbers are when you make an array, they would technically form a perfect square. For example, 2 times 2, when you build a multiplication array, would of course form 4, or a perfect square. And of course we can see the diagonals where those perfect squares can land on our multiplication table. We have 1, 4, 9, 16, 25, 36, 49, 64, and 81 going up to our 9 times 9 tables. So some square number examples. 1 times 1 is a square number. 2 times 2 is a square number. 3 times 3, or 9, is a square. And 4 times 4, which is 16, is a square. And when you think about it, if you were to graph these squares, you would be able to graph them into a perfect square. So now you're going to calculate all the perfect squares up to 15 squared. Go ahead and take a minute and do that now. So we notice that this is review. We're reviewing square numbers. 3 squared is 9, or 3 to the second power is another way of wording it. So make sure that you are taking a minute to go up to 15 squared. So your answers should look like this. Double check to make sure you did all of the multiplication correctly. For example, 13 squared is 13 times 13, which is 169. For your next activity, you're going to identify the following numbers as a perfect square or not. So next to the number, you are either going to identify yes, it is a perfect square, or no, it is not a perfect square. Go ahead and start on problems 1 through 6 now. So remember, it has to be the same number multiplied by itself in order to be a perfect square. Okay, so take a minute to see if your answers matched up. We have, of course, 16 is a perfect square because 4 times 4 is 16. 324 is a perfect square, as well as 729. We can see that 15, 146, and 300 are not perfect squares because you need the same number multiplied by itself to get a perfect square, and none of these have that in common. So now we're going to look at some square roots. So looking at square numbers, the large square has an area of 4 by 4, which means that the area is, of course, 4 times 4, or 16. The number 4 is called the square root of 16. And that's because, of course, 16 is a perfect square, and we consider the square root of 16 4. So when you think about it, square roots are the opposite of exponents. 4 squared is 16, and then we, of course, say the square root of 16 is 4. Kind of like how multiplication and division are inverse operations, exponents and square roots are inverse operations as well. For your vocabulary, a square root is a number which, when multiplied by itself, results in another number. For example, 5 is the square root of 25. 5 times 5 is 25. Therefore, the square root of 25 is 5. Make sure you have your vocabulary copied down. So let's look at how to find some square roots. We can use the following strategy to find a square root of a number. So you can either look at a number like 36 and know that 6 times 6 is 36, or you can factor out 36 into multiple perfect squares. Now you have to use multiplication in order to do this. So for example, the square root of 36 is also the same as the square root of 4 times 9, because 4 times 9 is 36. And you can then factor it out to the square root of 4 times the square root of 9, which of course is 2 times 3, which also results in 6. So you can see how you can get the same number by either memorizing all your multiplication really well, or by factoring out, which you're going to have to do a lot later when you get into more advanced math. So we can factor large perfect squares into smaller perfect squares in order to simplify word problems. So for your activity, you're going to find the square root of 256. Well, we can see in this sample, we can factor out 4 times 64, which are both perfect squares. And then those are simplified into 2 times 8, which can then result in 16. So take a minute and make sure that you have all of these steps written into your notes. And if you need to, you can always use a factor tree all the way back from previous chapters to help you identify perfect squares. So many of you would probably be able to factor out a 4. You would have to do some division in order to see that 4 times 64. But then you'd probably be able to recognize that 64 is a perfect square. If not, you could further factor 64 into more perfect squares. You'd just have more numbers to multiply. So that's going to bring us to your next activity, estimating square roots. So you're going to be given a series of problems, and I want you to practice estimating the square root. Make sure you double check your answers to validate that they are a perfect square. So looking at the first example, I want you to solve the square root of 25. So think of what two numbers can be multiplied together to get to 25. So in order to solve this, we can see that 5 times 5 is 25. So the square root of 25 is 5. And again, you don't have to write 5 times 5. You just write that the square root of 25 equals 5. Now I want you to try another one. Square root of 49. So think to yourself, what two numbers would form a perfect square in an array of 49? So we can tell what two numbers multiplied would get 49. We have 1 times 49, but that's not a perfect square. And the other problem that can be used to solve it is 7 times 7. So the square root of 49 is 7. Now let's look at a number like 27. Can two numbers be multiplied by themselves to get to 27? Well, again, we can start by listing all the factors. With some numbers, that's going to be very challenging, of course. But in this case, think about, is there a perfect square? Well, we have 1 times 27. We also have, 3 times 9. So 27 does not have a perfect square. However, we can estimate the square root. So it's not a perfect square. We have to use another method. And that's just like we factored out the previous problems, we can factor this in order to see, are there any perfect squares in there? Well, let's look. Something to remember, not all numbers are perfect squares. Not every number has an integer for a square root. We have to estimate square roots for numbers between perfect squares. So on a number line, the square root of 27 would be somewhere between the square root of 25 and 36 on a number line, because we have 5 here and 6 here. So 27, if you were to plot that on a number line, would be right about here. And of course, halfway between on the number line, we can mark here. So we can estimate, of course, 27 is about 5, and if this was 5 as a whole number, this was 6 as a whole number, and this was 5 1/2, is about 5 2/10. So when we estimate, we can put it in different terms. Again, think of them as whole numbers on a number line. About what fraction or decimal would it be at? So I wanted to end with common squares and square roots. So look at this list, and I want you, if you have the square root, I want you to find that. And if you're given a square, I want you to solve. So I want you to solve all of the square roots as well as the square problems. And make sure you have all of these completed by tomorrow. Anyways, feel free to contact me with any questions, and you can always continue with the discussion on the assignment board. So our goal was to identify perfect squares and find square roots of numbers, and now you're going to demonstrate your knowledge of that goal. Remember to try your best when solving the problems. Good job!